kind of funny. Okay, so let's graph this thing. So yes, I re-recorded yesterday. So we'll graph this equation on the left here in purple and the one below in blue. So we'll start with the blue one at +1. And from there, our slope's -1/2, so we can go down 1, right 2, or up 1, left 2. Draw your line. Now, shading these things, it wrecks some people. It's really not difficult, right? It's greater than. So if you think about the y values, where are the y values greater? The y values are greater above the line. So I'm just kind of like parking that mental thought in my brain. I know I'm shading above, and I'm just going to wait until I graph the purple to figure out where the shading overlaps. With the purple, we start at +3. From there, I can go up 2 to the right 1. I can also go down 2, left 1. And draw my line. So here's one little strategy for shading that I use. So the purple is less than right here. So where are the y values smaller? Either there or here. So sometimes the arrows help students, sometimes not. It's whatever works for you. The blue line is greater, so where are the y values greater than this +1? They're greater up here or up here. And then you shade the overlap where the arrows point towards one another. So our shading is all in there. You can plug in order pairs, you can plug in 0, 0. It's just a pain in the neck to do that. But if you get confused, you can always do that. Plug in 0 for x, plug in 0 for y. If you get a true statement, you shade towards 0, 0. If you get a false statement, you shade away from 0, 0. That's all. Okay? Many times, some of these kind of problems will ask you for potential solutions. So as we look here for potential solutions, you can pick where they intersect. You can pick any dot that's on the little grid, right? So any of these solutions over here, right here, you could pick as well, like any of those solutions if I have you pick some ordered pairs, okay? And then you just tell me what those ordered pairs are. Any questions on that one? Should be good. Okay, so got this one, x + 2y, less than or equal to 4. The other one I'll just write on top, greater than or equal to -x - 1. So on that bottom equation, I'm going to subtract x and divide by 2. So we get 2y less than or equal to -x + 4. And then we divide all three parts by 2. So we get y is less than or equal to -1/2 x + 2. That one we'll do in blue. The top one up here in purple. So try right now to get those two graphs, graph and shade, see if you can do it, and then I'll do it in a sec. Anybody in person need graph paper? I got some extra graph paper if you want some. High quality construction paper, graph paper. Anyone else? You? So my 6th period, you guys are still kicking ass. I was looking yesterday just to see, and we still have 22 out of 24 of you with A's. My lowest grade is like an 88 in this class or something like that. So Keep it up. That's awesome. We were just talking about, you guys may have heard, how much harder it's going to be next year when all of a sudden you go back to a regular schedule, taking 5 classes in a day. Kind of blows my mind to think about. I know that I really don't like this hybrid teaching thing as a teacher. It's just weird to have little 2-inch pictures of you guys on the screen and then people in person. So hopefully next year we'll be back to normal. Hopefully we won't be wearing masks. I pray. I don't want to see all the acne on your faces, right, from the mask. That's not pretty. Nobody wants to see that, including you. So graph and shape this thing. I'll start to do it here, so if you don't want to see, look away. Finish your graph and then look up. People screw up graphing negative slopes all the time. Remember this irritating, stupid face thing? Right? So negative, I just did it wrong now. Plus, is that right? I'm having a psychotic break. Plus and minus, I'm okay. Gotta love those moments you think you're losing your mind. Plus first, then minus. Right? So negative slope goes downhill, that's the way I think about it. And graph this thing. Again, we're thinking about the shading, so is it greater than or less than? Am I shading above or below this line? It's greater than, so I'm shading towards the origin, towards 0, 0, and I'm just kind of parking that mental thought. So we'll graph the second one. We start at +2. From there, we go down 1, right 2. So if I go down 1, right 2, again, this gap in between the dots and the line is getting bigger. So instead, I'm going to count up 1, left 2. So I'll just keep doing that because I know the shading part could be that tiny little wedge kind of upper left. It's not, but it could be. So you got to kind of extend your graphs out there. So it is, the blue line is less than, so I could shade in between there or down in that big section. Purple line is greater, so where the arrows point towards one another is where you shade. And in between there. So again, we're working up to these big back paragraph problem. We're going to graph and shade. We're going to take points in the shaded region and plug those into what's called an objective function. All kinds of madness will ensue. So to warm you up for the story problems, we're going to throw 2 at you in a row here. So take a second to read this one. We have inequalities on both these equations. I'll give you a minute to read it. So it says, your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for balcony seats, $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type must they sell? So we're graphing and shading here, so we have infinite answers, right? We're looking where that thing shades and overlaps, and we pick or repair a strongly overlapping shaded part. So this is a little crazy. We're going to have one equation for money. You look at that problem and you have $3 signs in that problem, of course you're going to have one equation for money. So don't make it any harder than that. So it's 20 bucks for balcony is X, so 20X. It's 30 bucks for orchestra is Y, so 30Y. At least, if I'm at least 10 of age, I'm at least how old? 17 or greater, right? So greater than or equal to for at least. Many times you guys will get confused, like what is at least, greater or less? Think up a scenario in your head and it will help you to figure out which way the inequality goes. So that's one of the equations. The other equation is the fact that there are 500 orchestra seats. Okay, so with 500 orchestra, remember orchestra is a Y, so it's just Y has to be less than or equal to 500. Maggie, you're unmuted, just so you know. So there's no X in that one, right? We're just talking about orchestra. That can happen in these kind of problems. So we got to solve this one. You could right away on this kind of problem, because everyone has a 0, just cross off a 0, right? That's a totally legal math move, as long as you cross off zeros on the ends. So I'm just going to rewrite what we have now. 2x plus 3y greater than or equal to 3,000. Then we can solve from there. Subtract 2x from both sides and divide by 3. So we get 3y greater than or equal to negative 2x plus 3,000. And then we're going to divide by 3. We're going to show you this one in the old graphing calculator, because we should. Y is greater than or equal to negative 2/3 x plus 1,000. And then we also have way up here, we got that y is less than or equal to 500. So there are the two equations. So bust out that graphing calculator, hit y equals. We'll throw, it doesn't matter where you put them in. I already have them in here. Oh, actually I don't, because I did a different problem at the end. So I'm just going to put the 500 one in y1, and then negative 2/3 x plus 1,000. Remember, you guys, the x is right next to the alpha key. And then, if you go back there, so even if you have an old school calculator, you go to the left of y1 and hit enter. If you have the old school calculator, this little symbol right here will just change every time you hit enter. So if you've got the newer calculator, you do it like this. That's greater than. That one's less than. So I'm going to look and see if I want to shade less or greater than 500. I want less than 500. So I'm good. So just go down and click OK. And then I want greater than 1,000. That one is greater than. So again, to review how to do that, you just go down here till that thing's highlighted, hit enter. If you have an old calculator, keep hitting enter until you get the greater than symbol right here. So then, we have to adjust the window, right? Both of these things at the end here are y-intercepts. So our y-intercept is, the bigger one is 1,000. So I'm going to hit window and make my y max. I'm not going to make it 1,001. I'm going to make it like 1,100. So a decent amount bigger than your biggest y-intercept. And then you know if I have 1100 for y max, x max can't be 10. Like, that's just crazy. That's not going to work. And that's just using common sense to realize that. So I'm going to guess it's 1,000. So 1,000 for x max, 1,100 for y max, and then hit graph. If you did the shading right, there's the y equals 500 line. And here, you got an error? Okay. How many people at home got a graph that looks like that, just so I know? Nice, good. Okay. I'm going to help people in person, so just give me one sec here. You good? Okay. Let me grab my glasses though. You good? Alright, let's see. Oh, so, hey you guys, turn your plots off. Cool. Thank you. So hit y equals. Turn your plots off here. Just enter.
Okay. How do I turn off the plot?
Just enter. Go up in y equals and hit enter, and it highlights on or off.
Oh, okay, cool.
Now shading. So hit y equals again, and go over to the little dash looking thing, and just keep hitting enter. The 2/3 you want greater, so that's just a thicker line. Enter there. That's greater.
Okay.
So then when you go up here, keep hitting it until it looks like less. Next one, yep. Now hit graph. It's just, you don't need the shade on your calculator, it's just kind of nice. Yeah, you did. Because you made your y and negative 1,000, so that's going to look kind of crazy. This one has too many zeros. Oh, wait, there's only got too many zeros too. Perfect. Okay. You good? Everyone good? Alright, excellent. So, if we're picking solutions, remember, we can do that second trace number 5 to get where the two lines intersect. So second trace number 5, enter 3 times in a row. First curve, enter. Second curve, enter. Guess, enter again. And that'll give you where the two lines intersect. So if you need a solution, that's a solution. You can also click trace, not second trace, just trace. And what it'll do is, if you hit the right arrow, those are points along that line, y equals 500. You'll notice that y always equals 500 along that line, and the x value changes. Every single one of those is also a solution. You can hit the down arrow, and it'll switch to the diagonal line, and then every single one along the diagonal line is a solution as well. Okay, and obviously you can pick points in this overlapping shaded part, but it's just an easy way to get the points from the graph. Just trace, second trace intersect to get where they do intersect, and then trace, and you can arrow back and forth along the lines. To switch between the lines, you arrow up and down. Okay, good deal.
Mr. Evans?
Yeah.
I got the same answer, but I just went graph on my calculator.
Turn, so if you go click y equals, and if your plot, so that plot 1 is on, plot 2 is off, so are your plots on?
My plot 1 is on.
Okay, so just hit enter and turn it off, and then hit graph and see if that works. Do you know how to turn it on and off?
Yeah,
Did it graph?
I graphed the bottom part, but not like the red part that you're showing.
Can you just hold your calculator up to the screen real quick? Okay. So hit y equals again.
Okay.
And then show me what that looks like. Okay. Should we hit window and show me your screen? That should be good. Oh, you have 11,000 for your Y max, not 1,100.
Oh.
That's why. I was determined to figure that out. Okay. And then your graph should look normal. Because you're above where that Y equals 500 line is. So that's why
Yeah,
you didn't see it.
now.
Okay, good deal. Cool. Alright, another story problem. Here's what I want you to do. Try to write the two equations. Okay, X is veggie topping, Y is meat topping. One equation money, write $3 signs, you want one equation for money. So there are little like shortcuts mentally you can take to these problems so you don't work your brain over too hard. Want to make it as easy as possible. Don't like graph them or anything, just write the equations, because if you write the wrong equation, it just makes it difficult. So you need two different equations. You have one equation money, one equation toppings. I just think about a little math nerd kid like going into a pizza shop and thinking like this. Like I wouldn't think like this either, so don't worry. So veggie is $1, so 1x. Meat is $2, so 2y. You have $10 to spend, so it's got to be less than or equal to 10. You can spend exactly all the money you have or something less. Then you want to have at least 5 toppings on your pizza. So your other equation is just x plus y, because you don't know how many veg or how many meat toppings you're going to get. And that one's also less than or equal to, or we want at least, so it's greater than. Greater than or equal to. So solve both those and graph. Subtract x, both equations, both sides. So on the left equation, we get 2y is less than or equal to negative x plus 10. Over here, we get y is greater than or equal to negative x plus 5. So the right equation, we're done. Left equation, like, the math is not hard, right? It's just a lot of stuff going on. Cracking, shading, figuring out, writing equations. Like, the individual pieces are not hard. It's the entirety of what we're doing that can be tricky. So we're going to graph one of these. We're both on another page. So you can start graphing as well. Try to graph and shade and see if you can figure out what's going on. Give me a couple order pair solutions. That's the kind of thing you'll have to do on your quiz. So both equations start at plus 5. Do the top one in blue, bottom one in purple. So I'm going to graph the bottom one first. I start at plus 5, go down one, right one, and I'm going to count all the way until I get to the x-axis. Technically, when I graphed this thing, I kind of forgot, but it doesn't matter. I only need to show quadrant 1 when I graph, because we're not going to have negative pizza toppings, so that's why I'm only showing the positive quadrant, quadrant 1. Then I draw my line. Then we'll graph the blue one. Again, starts at positive 5. That one goes down 1, right 2. And I'm going to go all the way until the right, until the x-axis again. So I shade below the blue, above the purple, so we're in that kind of middle sliver. Many times when you do these problems, the answer will be over here in the corner. This is not one of those problems. So we can pick so many order pairs for the solutions. Right? I could pick the corners. The shaded part is called a feasible region, like where the solutions work, where they can exist. So I could pick those corners. I could pick every one of these dots along each of the lines. I can also pick every dot in the middle here. Right? I could also pick these down here. So every single one of those green dots, you don't have to write them all, but every single one of those green dots is a potential solution, right? Between veggie and meat toppings. Okay, so that's that. That was done. Okay, so now we're graphing a line and an absolute value. Remember, absolute value graphs look like a V. Okay, now to you, they look like a V. You got to have that V shape when you graph these things. So we've got this section I skipped from chapter 2, which talks about transformation of functions. So what does that mean, transformation of functions? That V shape, we can move that V shape up, down, left, right on a graph. We can also make that V super skinny. We can also make that V super fat. Just kind of depends. Okay? So we're going to talk about how to graph these V's because it's really not hard. So we're going to graph and shade with a line and an absolute value. They could give you two absolute values, so don't freak out if that's the case. But y equals 3, show me at home and in person, are we talking vertical or horizontal line? Yeah, see, people are confused. All right, so keep your hands up or keep thinking what you were thinking. Y equals 3, which axis does it cross, y or x? Y. So what is it, horizontal or vertical?
Horizontal.
Horizontal.
Oh,
Cross is the
vertical.
Y, right? Yeah. Cross is the Y, so it's got to be horizontal. Because that messes with people's heads for sure. But I just look at this and I think it's Y equals, so it's got to cross the Y axis, right? And then it's easier to think about. So let's draw the Y equals 3, so 1, 2, 3. So if it's x equals, that's the vertical. If it's y equals, that's horizontal. So if it's x minus 1, the absolute value of x minus 1, the minus 1 makes that absolute value graph move to the right 1. So almost all of these absolute value graphs, the slope is up 1, right 1, and up 1, left 1. So up 1, right 1. And up 1, left 1, and then that makes our V. So the minus 1 in here, this makes it move to the right 1. So when I say it makes it move, it makes the vertex of that thing move to the right 1. because the absolute value of x starts at 0, 0, and then the b goes from there. So if we go -1, you would think it would go left 1, but it actually goes right 1 because of the absolute value. Okay. If we think about graphing this, it's below the horizontal line and above the b. So it's this little triangle in the middle. I'm going to show you how to graph that on your graphing calculator as well. But I'll give you a sec to break this graph down. So, graphing this on the graphing calculator. Remember, our window's all jacked up. We switch it to like 1,000 or 1,100. So if you hit zoom, top middle button, 6, that takes us back to a standard window. And then if you hit, that thing crawls across like that. If you hit on, it'll eventually stop the graph so you don't have to watch it crawl across so slowly. It's kind of maddening. Then hit y equals. Erase your two equations here. So the less than equation, because my y1 is less than, I'm going to put the 3 there because that's already less than, and then I don't have to mess around with those inequalities. Now, to put in absolute value. Okay, to put in absolute value, hit math, which is right below alpha. You can tell on my calculator online because the button's red. You hit the right arrow over the number. So you see number up top right here. And then absolute value is the first one. So you just hit enter. I'll do it again. Yeah, absolutely. So right here we hit math. We hit the right arrow over the number so you can tell the number is highlighted here. And then just enter to get that absolute value. If you have an older calculator, it'll say ABS with an open parenthesis instead of the two absolute value bar things. And then we can just put in x, which is right to the right of alpha, -1. And then when I hit graph, it should all work out.
Do I close the parentheses?
You don't have to, but I would always close the parentheses.
Okay.
Because, like, unless you have an intimate knowledge of order of operations, nobody does, just close the damn parentheses. Then you don't have to worry about it. So if you hit graph, there's the y equals 3. And then our b comes in. I just think it looks kind of cool. Honestly, you don't need to do this ever. But I just like seeing it, right? And sometimes it'll help you just to figure stuff out. So the overlapping is obviously in the middle. Remember, you can click that trace thing. So right here, I'm along the y equals 3 line. All of those are solutions. I can hit the down arrow, and then it will go to the b. And then you can go left and right along the b. These are all skills, like introductory skills that will, I'll make it much more difficult. So I try to show you everything I can show you on the calculator right away. So we could do 0, 1 as a solution. We could do that nasty decimal, no thank you. Right? And just go along until we find good decimal answers we could use. Okay? Any questions on that? We got one more of this type to graph, and then we're done. So take a sec, write this one down. So I'm showing you what happens when we have a number in front of the absolute value, like we do right there. And you can just think of that number in front like a slope. So instead of going up 1, right 1, I'm going to go up 2, right 1, and up 2, left 1 with the b. You should all know how to graph lines by now. So graphing that line, I start at +1 and I go down 1, right 3. And I go up 1, left 3 as well. Draw my line. And then with our absolute value graph, the -1 makes my vertex move to the right 1. And then, like I said, we're going to treat this like a slope, 2 over 1. So from there, I'm going to go up 2, right 1, and up 2, left 1. Up 2, right 1, up 2, left 1. So what that does when you multiply the absolute value function by 2 is it makes the absolute value skinnier as opposed to wider, right? Skinnier. And then you can just draw that graph. And that is it. So, you know it's going to be that tiny little spot, right, in between the blue and the red, right in there. That's what the book always loves to do. So it's less than the blue, greater than the red, so yes, indeed, it is that tiny little spot. Right there. That I did in purple. So good luck getting that over pair as a solution. You can always do the red dot at the bottom, right, as a solution if you need to. And then I wouldn't give you one like this because it's just stupid as far as getting other solutions. Okay? That is it. There is your homework. Number 9, do not use a table. Just graph and shade. Your homework is already posted. It's a bunch of kind of random problems. Page 153, 9 through 19 odd. I'll just wait so you can just see it. It's easier that way. So there it is. Page 153, 9 through 19 odd, 20, 21, 32, and 48. Always, if I pick problems like that at the end of the assignment, trust me, it makes your life easier. I'm picking like specific problems I want you to do. So you have a ton of time. You got 40 minutes to work on this. That is it. I'm going to stop my recording so I remember this time.